Firstly, simply insert the red dot into the probe line. Then click on Power on, click F1 to continue, and this will display the mode it displayed during our detection. We usually display the detection based on impedance and vertical coordinates, and then we need to set and adjust it. Actually, we have already pre-adjusted it for you. Do not touch the channel. There is no need to adjust it. It should be noted that it is necessary to ensure that the probe mode is DP. This probe is equipped with Add P mode probe for you, and it must be matched properly before using DP mode for detection. Then we need to enter to confirm. This is an area where it will trigger an alarm. You have the same interface as when we tested it. The signal will appear in the middle, and a pop-up signal will appear. If this signal enters the red box above and will sound an alarm, then what we are adjusting here is this red box, its shape and the size of its range area. You seem to have square boxes and fan-shaped boxes. Mainly these two types of boxes. Generally, fan-shaped boxes are more commonly used because they are a circle, they are circular, and emit a signal in all directions. And here is window A, which is the window above. It can be resized, while window B can be resized. We usually default to 5 up and 5 down, and currently there is no need to adjust it. Then we can start testing. Let's go to the detection interface and click once to enter the box. The detection is currently in a paused state. Then click enter again. It will turn into a triangle, indicating that we are currently in the detection state, and we can proceed with the detection. When testing, we ask the probe to look at this probe. There is a downward arrow pointing in this direction, which is the front end of your probe. That means when you move, you need to move towards this front end. You can't say you are leaning or spinning like this. It's not right. You must move forward according to the position indicated by the arrow. Well, if it is a smooth plane, then there is no signal when we move forward. Its signal is very stable, and if it encounters some fluctuations in the middle, such as when I pick it up now, it will also fluctuate because it will have some fluctuations, roughness or some, for example. If we want defects, there may be some changes. So what we need to do is to distinguish between the defect signal and some rough clutter on the surface. We didn't see it on this test block. Once that effect occurs, what is the signal like? There will be an 8-shaped signal. On the screen for you to see. This is clearly an 8-shaped signal, which is a defective echo, so we have carved grooves of different depths here. 0.1, 0.2, 0.4, 0.6. You can judge our testing requirements based on this standard. How many millimeters do we need to detect and the size of that effect when we debug? We need to ensure that we first adjust our gain above the gate. What is the gain? Here let's first change the down arrow to gain. One is H, and the other is V. Is one of its adjustable gains, which means it amplifies the height of the signal. up and down by a factor of the amplified signal up and down. Like this, if I make it very small, its signal will become smaller. If you look beyond the screen, it will be in a relatively small state now. If it is even smaller, it will not sound an alarm. So we adjust its gain value to keep the defect signal within the alarm area, including the horizontal gain of V below it. At present it has a certain inclination. If the gain is increased, it is equivalent to amplifying the signal in this direction, amplifying it in one direction. After we shrink it, it will shrink in one direction. If its signal is already on the far left, then if it moves further to the left, it will move to the right. What about the phase below? If we click Set at this time, we can adjust the gain signal on both sides simultaneously. Then we go down the arrow, followed by the phase, and now we see that this signal is basically within this range. If we adjust this range to move up and down, you can see that when I adjust it, it is constantly rotating, which is a phase adjustment from 0 degrees to 360 degrees, and the signal will rotate. We also need to ensure that this signal is in the alarm, so we can adjust the phase appropriately in this alarm situation. What we need to do internally is the defect signal. We need to ensure that by adjusting the gain, adjusting its height, and adjusting its phase, the amplitude of its rotation requires us to ensure that the defect signal is within the alarm zone, and some of our interference models, such as rough surfaces, may have slight noise, which we control outside the alarm area. Basic testing is mainly focused on these aspects. Then F1 is storage, which is equivalent to saving this signal graph. Clicking on it will store it in the form of dates.